Hi guys, welcome to the last part of stoichiometry. The good news is this is all stuff you've done. So it's not anything new. What you're really doing is just combining everything into one equation. So what you end up with is an equation that has 3 different conversion factors in it, but you know how to do all of them. So the way it works for gram-to-gram stoichiometry is you do have 3 conversion factors. The first conversion factor converts grams to moles because you start with grams and then you convert those to moles. The second conversion factor is the mole ratio, like you used earlier this week, and it moves you from one compound to another compound in the equation. And then the third conversion factor converts the moles of the second compound back to grams. In order for this to work right, you have to have a completely balanced equation, and you need to calculate both molar masses for each of the compounds. Okay, so we're going to go through a couple examples. Both examples are going to use this equation here. 5 moles of F2 plus 2 moles of NH3 yield 1 mole of N2F4 and 6 moles of HF. Now your first question is, if you have 50 grams of F2, how many grams of HF will be produced? So the first step is to calculate the molar mass of each of the 2 compounds you're being asked about. So in this case, F2, you have 2 atoms. The average atomic mass of fluorine is 19. 2 times 19, 38 grams per mole of F2. For HF, you have 1 atom of hydrogen and 1 of fluorine. Hydrogen's average atomic mass is 1. Fluorine's is 19. So essentially 19 plus 1. For HF, it's 20 grams per mole. Each of these molar masses give you 2 possible conversion factors. For F2, you have 1 mole of F2 on top and 38 grams on the bottom, or you have 38 grams on top and 1 mole on the bottom. The same thing for hydrogen fluoride. 1 mole of hydrogen fluoride can be on the top or it can be on the bottom. You choose which conversion factor to use based on the units you need to cancel out. The next step is to determine the mole ratio. This is what you did earlier this week. So in this case, we're comparing F2 to HF, or fluorine gas to hydrogen fluoride. I go back up to the equation. I have 5 moles of F2. I have 6 moles of hydrogen fluoride. So my mole ratio is 5 to 6, which gives me 2 possible conversion factors. I can put 5 moles of F2 on top, or I can put 5 moles of F2 on the bottom. Again, I choose based on what units I need to move around. Just a quick reminder, you can find a copy of these notes on Google Classroom. So we're just going over what you have access to. So let's set up this first problem. In the problem, I was given 50 grams of F2, and it wants to know how much HF will be produced. So I start by writing down what I'm given. I'm given grams. So the conversion factor I'm going to choose to get rid of grams will be this one here. 1 mole is on top, 38 grams is on the bottom. So 1 mole of F2 over 38 grams. That allows me to cancel out grams and move to moles. The next conversion factor is my mole ratio. I choose the mole ratio that lets me move from one compound to the other. In this case, I want to get rid of moles of F2. I want to move to moles of HF. So moles of F2 go on the bottom, moles of HF on the top. So now I'm canceling out moles of F2, and I've moved to moles of HF or hydrogen fluoride. Now I have to convert my moles of hydrogen fluoride back to grams. So again, I'm choosing a conversion factor. In this case, I have to choose the conversion factor that puts the mole on the bottom and the gram on the top. So I have grams to mole ratio, so I change compounds, and then moles back to grams. The easiest way to do this is to multiply all the way across the top and get a number. In this case, it's 6,000. Multiply across the bottom and get another number. In this case, it's 190. And then you simply divide, and you end up with 31.6 grams of hydrogen fluoride if you start out with 50 grams of fluorine gas. Okay, we're going to use the exact same equation again, but this time we're going to move in a different direction in the equation. This time we want to know how many grams of NH3 are needed to produce 120 grams of N2F4. So we're starting with a product and we're moving backwards to a reactant. It doesn't matter. Mole ratios, you can move anywhere in an equation. So the first thing you're going to do is you're going to get the molar masses of the two compounds in the equation or in the question. So you have N2F4 and NH3. For N2F4, you end up with a molar mass of 104 grams per mole. For NH3, you end up with a molar mass of 17 grams per mole. Each of those molar masses gives you two different conversion factors. For N2F4, you have 104 grams on the bottom and 1 mole on top, or you have 104 grams on top and 1 mole on the bottom. The same thing for NH3. 1 mole of NH3 can go on the top or the bottom. You choose your conversion factor based on your units. The second thing you need to do is establish your mole ratio. If you go back and look at the equation, in the equation there's 1 mole of N2F4 and there are 2 moles of NH3. So 2 more possible conversion factors. You can have NH3 on the bottom or NH3 on the top. It doesn't matter. It's just a matter of what you need inside the problem. So then the last step is just converting 120 grams of N2F4 to figure out how many grams of NH3 you need for the reaction to work. So you start by writing down what you're given. In this case, you're given 120 grams of N2F4. You have to convert grams to moles, so you choose the conversion factor that puts grams on the bottom, so this way your grams cancel out. You now have 1 mole of N2F4. Here's where the mole ratio comes in. You're going to put N2F4 on the bottom so I can cancel it out, and I've now moved to moles of NH3. Then I have to convert moles of NH3 back to grams to get my answer. So in this case, I just 1 mole of NH3 on the bottom, 17 grams of NH3 on the top. Now it's the exact same process. Multiply everything across the top. You're going to get 4,080. Multiply everything across the bottom, which in this case is really easy. It's 104. And then you simply divide. So you would end up with 39.2 grams of NH3. What this means is you need 39.2 grams of NH3 to produce 120 grams of N2F4. In the notes, you will find a second you'll find a second example that goes literally step by step of how you to set this up. It's a whole separate set of notes.